Alright, here's your practice final exam solutions. I'm going to do it in two parts. This is the first 20, and then I'll do the second 20 in another video, just so it won't be like an hour and a half long for just a single video. Alright, find the slope through the pair of points. You can use the slope formula. M equals y2 minus y1 over x2 minus x1. Alright, y2, either one you can call y2, it doesn't matter. I'll call that second one y2, minus from this and a negative 6. Okay, don't forget it's a minus a negative, don't forget to put that second negative. Alright, then x2 has to be the value that went with this y, whatever y you picked here. So we picked negative 2, so x2 has to be 7 minus 2. Alright, so minus and minus is a plus, so negative 2 plus 6 is 4, 7 minus 2 is 5, so I get 4/5. Now, everybody always wants to know how can I do stuff on a calculator, so I'll just have this up over here and show you how to do some of the stuff in your calculator. So under your stat menu, under the editor, you can input x and y values. So if I put in the two x values, 2 and 7, in the L1 column, and then in L2 put in negative 6 and negative 2. Alright, it has to be that these match up left to right. 2 negative 6, 7 negative 2. Alright, if you got your points put in there properly, press the math button. I'm sorry, not math, stat button. Come over to calc. Alright, and then come out to linear regression. Notice it has ax plus b, and we're used to seeing y equals mx plus b maybe. They're just replacing the letter m, which represents the slope, with a, which represents the slope. But the slope is whatever's in front of the x, or the variable. So we're going to choose option 4. Hit enter. Alright, there is our slope a. Right, and if you want that as a fraction, just type in 0.8 and tell your calculator to turn that into a fraction. Alright, and then there's the 4/5. Alright, now either way you do it's fine. I don't care how you do it on the final. You're going to need to practice doing this and figuring out how to do it. So whichever way you want to do it's fine. So for number 2, let's just practice with the calculator. So edit x values in L1, so a negative 9 and a negative 9 again, and then in L2 a negative 7 and a negative 5. Right, after you hit that, press stat, come over to calculate. Alright, linear regression, and we're after a. Now it says error, go to domain. When you see that, that's a hint that you have an undefined slope. So that means that this is undefined. Alright, if you did it by hand using the formula again, if this is y2 minus y1 is negative 7, x2 minus x1, anytime you subtract something from itself, you always get 0. So plus on the top we get a 2, but on the bottom we get 0. Right, and division by 0 is undefined. Alright, find the slope of this line. So it's just very similar to what we've just been doing. 2 points that are known. There's y-intercept. That looks like it's at 0, 1. Alright, and then another point that looks like it's on this line. Looks to me negative 1, negative 1 is on here. Alright, so y2 minus y1 over x2 minus x1. So negative 2 over 1. Don't leave it like that. If you can simplify it, simplify it. Negative 2 over 1 is negative 2. So our slope is negative 2. Alright, again, finding the slope. This is a horizontal line. Alright, horizontal zero slope. So here our slope is 0. Alright, vertical line has a undefined slope, as we saw up here. This was undefined. This is a vertical line if you plotted it. And then this is a horizontal line that has 0 slope. Alright, big difference between those two. Alright, 5 wants us to find the x and y intercepts of the graph and then graph the equation. So the way I do this, if I'm doing a x-intercept, that means y is equal to 0. A y-intercept means x is equal to 0. Okay, so for the first part, the x-intercept set y equal to 0, so that means I'm just left with 6x equals 36, because if y is 0, this whole thing is gone. And that leaves me with x equals negative 6, right, dividing both sides by negative 6. So there's our x-intercept, negative 6, 0. Alright, y-intercept, go back and set x equal to 0, so that means I'm just left with a negative 18y equal to 36. Alright, divide both sides by negative 18, I get y equals negative 2, so that means 0, negative 2 is on this thing. Alright, so negative 6, 0 is right here. 0, negative 2 is about right there. Alright, and then I'm going to connect this thing with a line. Alright, there through there, and then there through there. Alright, so there's our line. But all we need is the x and y intercept to graph that. Anytime you have a problem like this, even if I don't even tell you to use the x and y intercepts, you should get yourself to the point where if this coefficient of x divides the constant and the coefficient of the y divides the constant, and the x and the y are on opposite sides of the constant, this intercept method should be what you think of, because it's what's going to be the easiest method to do it. Alright, find the slope of the line if it exists, and the y-intercept if it exists. So to do that, we want to get this thing in slope-intercept form. So we want to solve for y, or isolate y, and have mx plus b form. And if we do that, the number in front of x is the slope, and the number that's the constant will be the y-intercept. Alright, so let's see what we're going to have to do to isolate this y. First thing we're going to need to do is subtract 6x from both sides. And to make our way towards this form, I'm going to put the x term first and the constant second when I rewrite the right side. Alright, so negative 6x is going to come first, and then minus 18 is going to come second, again to get us towards this form. Divide away the negative 9, and when we divide a difference or a subtraction by a number, we divide the x term and the constant term by that. So I end up with a y equals negative 6 over negative 9. If you're not comfortable with fractions yet, hopefully you'll get comfortable soon, but if you're not there yet, negative 6 divided by negative 9, you can do it on your calculator. Hit enter, or you don't have to hit enter, just press math 1 into fraction, and you'll see it'll take away those negative signs and it'll reduce the fraction. Okay, so that's going to be a 2/3 x, and you should get yourself to the point where you don't need to rely on a calculator to reduce something like that for you. There's 2 negative 3's in negative 6, there's 3 negative 3's in negative 9, so that's going to reduce to a positive 2/3. And then again, a negative divided by negative is a positive. 18 divided by 9 is 2. Alright, so there's our mx plus b form. So now the number in front of the slope is the number in front of x is the slope, so that's the 2/3. So the slope is 2/3, and then the constant, the number out here by itself, is the y-intercept. So the y-intercept is 2. Or if you write it as a point, it's 0, 2, technically. Alright, write the equation line with the given conditions. Passing through this point perpendicular to this line. So the first thing we want to do is isolate y here. So again, the number in front of x is the slope, because you need the slope here. So I'm going to add that 8x over, and I get y equals 8x plus 5. Okay, so that means the slope of the first line is 8. Alright, now remember, to be perpendicular, I'm going to put a little p down here, the slope of the perpendicular line, that's what that little subscript p means. We want not only the reciprocal of this, the reciprocal of 8 is 1/8. We want the negative reciprocal, the opposite reciprocal. So we want negative 1/8 for our slope. Alright, so that's one thing we need. There's our point. We're going to use the point slope form. Point slope says y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. And then you just simplify and isolate that y, and you've got the slope intercept. Alright, so y minus the y coordinate of the point is 2. So y minus 2 equals the slope we need is this negative 1/8, because we want it to be perpendicular. X minus the x coordinate of the point is 4. Alright, now technically I didn't specify, but usually the equation we want is y isolated. So we're going to distribute this negative 1/8 through, and then finally add that 2 over at the very end. So negative 1/8 x, a negative times a negative is a positive. 1/8 of 4, again, you should be able to do that in your head, but if not, go to your calculator. 1/8 times 4 is 2. I'm sorry, 1/2. 0.5 is a decimal, but since we have 1/8, a fraction for the slope, we want a fraction for the constant part too. So use your end of fraction feature if you're not comfortable with changing decimals to fraction, but again, that's 1/2 and 0.5. That should be something that we know already. Alright, then last thing, add the 2 to both sides. Over here, instead of writing it as 2, I'm going to write it as 4 halves, so I can do this addition. Alright, and so I end up with y equals negative 1/8 x. 1/2 plus 4 halves is plus 5 halves. And there is our answer. Number 8. Write the equation line whose graph is shown. Again, this is one where you gotta find the points on here. So it looks to me like that's a point on here. The x-intercept looks to be at 6, 0. The y-intercept looks to be at 0, negative 4. Alright, so I can use my calculator to do this. I can do it by hand. It doesn't matter. It's fine to me if you use your calculator. So plug in those 2 points. Stat, edit. Alright, our x coordinates are 6 and 0. Our y coordinates that correspond to those x's are 0 and negative 4. Stat, calc, linear regression. That'll give us the line. Alright, a is that. Now if you don't recognize that decimal, again, just put it in. Make a whole line of those 6's and a 7. That's a repeating 6. and then hit math and diffraction, and that'll tell you that that's 2/3. Alright, so that slope is 2/3, and the y-intercept obviously was -4, which we got written there. So that means our equation was y equals 2/3 x minus 4. Okay? Since we identified the y-intercept, it wouldn't be bad to do this one by hand. y2 minus y1 over x2, over x2 would be 0, minus x1 is 6. That gives me a -4 over -6, which reduces to 2/3. So that's our slope, and there's our y-intercept. So when I'll go into y equals mx plus b form, alright, m is the slope, which is 2/3. B is the y-intercept, which was -4. So this one wouldn't have been bad to do by hand anyway. Alright, find the average rate of change of the function over this given interval. Okay, x squared plus 7x between x equals 3 and x equals 7. So when you're doing this, you need to find the outputs. You need to find the y's at these x's. So plug in 3 into this thing, and you get 3 squared plus 7 times 3. That equals 9 plus 21, which equals 30. Okay, that's like your y1, and this is like your x1. And then plug in 7. 7 squared plus 7 times 7. That equals 49 and another 49, which equals 98. And that's like your y2 to this x2. And remember, average rate of change is just like slope. So y2 minus y1, 98 minus 30 over x2 minus x1, 7 minus 3. Alright, 98 minus 30 is 68. 7 minus 3 is 4. 4 goes into 6 one time. Remainder of 2. 4 goes into 28 7 times. So our average rate of change, which you can just abbreviate AROC, is 17. Alright, once again, find average rate of change. This is just computationally the definition of average rate of change. You plug in the x's to get the y's, and then you find the slope between those 2 points. But here's theoretically what you're doing. You're finding the slope of this line through these 2 points. That's technically not really even there. Okay, so you're finding the slope of that line. So again, y2 minus y1 over x2 minus x1. 1 minus 7 is -6. 1 plus 2 is 3. So over that interval we got a slope, or an average rate of change, of -2. Alright, regression. So I gave you the grade point average of students at some community college. This is their age, this is their GPA. Right? And we want to use the regression line. We're going to find the regression line determined by your calculator. That shouldn't say use, sorry, that should say find. So we're doing a line of best fit problem here. Alright, so I need to put the ages in. Again, go to your stat menu, edit. I need to put the ages in Y1 or L1, that's the X's. So I'm going to put all of those in. Okay, and I've got all the GPAs in there as well. Alright, to find your regression line, stat, come over to calc, linear regression, what we've been using to find the lines between 2 points. It can also give you the regression line between several points. Alright, oops, that's one of our stats. Sorry, I hit enter instead of scrolling down to 4 before I hit enter. Alright, linear regression. So there's our slope, there's our y-intercept. You can round these things to 4 places. So y equals 0.1011 to 4 places roughly. X, alright, and then your y-intercept was 0.7089 roughly to 4 places. Alright, next problem. More regression again. I'm going to give you something where you would either come up with a linear model or need to know how to use a linear model. This particular problem, I give you the linear model. That would be to, if we did regression on this data set, this is what we would come up with. But this time I want you to use it. Use the model to predict the score on a test of a student who studies 2 hours. So this is the hour studying, that's X. Alright, Y is their score. So their score is 67.3. It's a base value if they don't study at all, plus a 1.07 points for every hour they study, which is X. Alright, we're going to plug 2 in there. So 67.3 plus 2.14 equals 69.44. Alright, or again, you could just go to your calculator and plug it in. 67.3 plus 1.07 times 2. Hit enter. There's their number. Okay. Alright, a set of data consists on the number of years that applicants for foreign service jobs have studied German and the grades that they receive in a proficiency test in the language. Alright, the following linear model is obtained. X represents the number of years they study, Y represents the grade of the test. What does the slope of the model represent in terms of the grade on the test? So this is interpreting slope. If you ever see me write interpret slope, this is what I'm talking about. Alright, so here's our slope. Slope is the number in front of the X variable. So 10.9. Now, what you remember, slope is the change in Y's over the change in X's. Alright, so this is Y. A lot of times when we deal with division with word problems, the division bar is read per. Like think of miles per hour, feet per second, dollars per hour, dollars per year. So per is a lot of times what we read a division bar as. So this is 10.9 Y units per X units. Well, what are the Y units? Alright, Y is the grade on the test. So points per, and then what's the X units on the bottom? Oops, that should be an X1. Sorry about that. What are the X units on the bottom? They are years studying. So points per X units are year. Right? Since this is a decimal, it's kind of like our denominator's 1. 10.9 over 1. Right? So that's 10.9 points per 1 year. Right? Now, that's not enough, alright? That just kind of gets you started with it. But you would need to write a sentence. What does the slope mean in the model in terms of grades on the test? That's positive. So grades increase because it's a positive slope on average by 10.9 points for each year of study. Alright, you do need to tell me that it goes up or down, alright, and then obviously you need to understand the interpretation of the actual number. Right? You need to include the number too. Do not forget to include that number. Interpreting the slope and not putting the slope in there, you just wasted paper if you didn't put it in there, the number itself. Alright, here's revenue and cost functions. We've seen so many of these this semester with our little bouncy ball operation problems or in labs. Hopefully you know how to do this. Alright, set R equal to C. This time I give you R so you don't have to compute it. You don't have to multiply anything by X. This is R. So set R equal to C and solve for X. So 233X equals 43X plus 872,000. Alright, isolate the X's, group them together. Group the constants over there by itself, and then divide. Alright, and this on this side will be 190x equals this 872,000. Alright, divide both sides by 190 and you get 872, 123 divided by 190 equals that. Now we want to find the break-even point, round your answer to the nearest whole unit. So since we don't get a whole number there, we're going to round it to 4589. Alright, number 15, Jim's got scores of 67 and 89 on his first two tests. What has he got to score on that third test to give him that B average that he wants? Okay, so how do we get an average? We take the numbers, this third thing we don't know, so what must he get? That means we don't know it, so we add X to represent that third number to have an average of 80 or greater. So we're going to divide that by 3, and that's going to be greater than or equal to 80. So this is a linear inequality problem. Alright, now what am I going to do first? I'm going to multiply both sides of this thing by 3. That'll get rid of. Alright, 67 plus 189 is 67 plus 89 is 156 plus X is greater than or equal to 80 times 3 is 240. Subtract away the 156 from both sides, and I get X has to be greater than or equal to 240 minus 156 is 23, 14, 84. Alright, so he has to make an 84 or better to maintain that 80 plus average. Alright, 16 wants us to solve this quadratic equation. So to solve a quadratic, we want to bring everything to one side. So I'm going to bring this 1200 over to the left. And now I've got a quadratic equation set equal to 0. Alright, all the numbers are even, so I can factor a 2 out and divide it away since this is a equation. So basically I can just get rid of a factor of 2 in all these. So 124 divided by 2 is going to be 62. And then 1200 divided by 2 is going to be 600. Alright, now I'm looking for, if I want to factor this thing, I would need two numbers that multiply to 600 and add to negative 62. So they're both going to have to be negative for this to work. Alright, and then two numbers that multiply to 600 and add to 62 are going to be 12 and 50. Alright, and then if you need to multiply back out, FOIL it back out and verify you get this. S and S is S squared, minus 12S minus 50S is 62S, and then negative 50 and negative 12 multiply to positive 600. So our solutions are what makes each of these individual factors equal to 0. So set each one equal to 0. And yes, I apologize, my S's look like my 5's. So S is equal to 50, or S is equal to 12. So there's our solutions to this thing. Alright, and you could also have used your calculator to help you to do this problem. Alright, the reason why I didn't show you how to do the calculator on the last one is because this one I actually want you to, and then round your answers to 3 decimal places if you need to. So you can do one of two things. You can type in x squared plus 7x, just the left hand side, in y1, and then the right hand side in y2. I want to hit zoom 6 because I don't know what my window was before. Graph it, and we want those two intersections. So second calc, option 5 is intersect. Alright, first curve, that's the quadratic. Second curve, that's our horizontal line. There's a guess. So there's one solution. Alright, to 3 decimal places, that's negative 0.807. Or the other one over here, option 5. First curve is the parabola. Second curve is the horizontal, and I'm using the horizontal to get over there a little faster. Alright, and then there's the guess. So x equals negative 6.19 to 3 decimal places 193. So negative 6.193. Alright, so there's my solutions to this thing. And again, I don't have any division by x in the denominator. I don't have any square roots of x, so I don't have to worry about restrictions. It's a good idea to check, but you know, as long as you have your equations in there, you should be fine. Now the other way to do this problem is bring that 5 over, meaning add 5 to both sides and set this thing equal to 0. If I did that and graphed it, now I'm no longer looking for an intersection, now I'm looking for the zeros. So if I did the 0 feature and then did the left bound, right bound stuff like we did before, we'll get these same two x values. Alright, the y value is no longer equal to negative 5, it's now equal to 0 because we added 5 to both sides, but still there's the negative 0.087. If you did the same thing for that one, you would have gotten this. Alright, so either way is fine. Alright, 18. Find f of 5 for this. Alright, 5 is our value for x. Which of these pieces of the domain, which of these parts of the domain does 5 fall? 5 is not less than 1. 5 is not greater than 10. 5 is between 5 and 10 inclusive. Right, so 5 is included here, so we plug it in to this middle one. Alright, so f of 5, we'll take the input 5 and multiply it by 5. So f of 5 is 25. Alright, then the last couple. 19, we've got a absolute value equation. It's ready to go. As soon as you have the absolute value thing isolated, you're ready to go. So your first equation is just dropping the absolute value bars. There's one equation you had to solve, but you had to remember, the one everybody forgets is dropping the absolute value bars and negating the other side only. Don't negate the side that had the absolute value bars to begin with. Only negate the other side. Alright, and then isolate the m in both of these. Alright, divide by 6. So we get m equals 5/6 as one solution. Or subtract 2. 6m equals -9. Divide by 6. Divide by 6. M equals, this reduces to a -3/2. So there's our two possible solutions, 5/6 or 3/2. Alright, quadratic function that best fits that data set. So hit your stat button, go to the editor, clear out data. Don't hit delete, clear out data. If you hit delete and lose your values, you can get them back, but you won't have L1 and L2 anymore. So you will need to do the setup editor to get it back if you accidentally do delete that. 35, 95, 116, and 78. Alright, I want the quadratic of best fit. So again, I go to stat and I go to calculate, but instead of linear regression, right underneath that is quad or quadratic regression. So I hit enter and it wants coefficients or constants rounded to the nearest hundredth. Alright, so that's going to be -0.398 rounded to the nearest hundredth would be -1.40. So y equals -1.40 x squared plus 27.15 x alright, and then minus 14.44 as our constant. Alright, so that's number 20. The next 20, the last 20 will be on the next video.